this video, we are going to solve questions number 10, 11, 13, and 14 on section 1.3 of the textbook. Question number 10. A medicine is administered to a patient. The amount of medicine M in milligrams in 1 milligram of the patient's blood T hours after injection is M at T equals -1/3 T2 plus T when T is greater or equal than 0 and smaller or equal than 3. A. Find the rate of change in the amount M 2 hours after the injection. B. What is the significance of the fact that your answer is negative? Without solving the question, we know M at 0 is 0 and M at 3 is 0. That means at the beginning there is no medicine in patient's blood, and after 3 hours the amount of medicine is 0 in the patient's blood. And we know the answer should be negative because as time passes, the amount of the medicine in the patient's blood is decreasing. Part A, we are looking for instantaneous rate of change of function M with respect to T at T equals 2, which is M at 2 plus H minus M at 2 divided by H as H approaches 0. M at 2 plus H is -1/3 times 2 plus H to the power of 2 plus 2 plus H. And M at 2 is -1/3 times 4 plus 2. If we do the algebraic manipulation, we see this limit is equal to limit of -1/3 times H minus 1/3 H2 over H as H approaches 0. After plugging 2 plus H into the function, we expand 2 plus H to the power of 2, which is 4 plus 4H plus H2, and do the algebraic manipulation. If factor H in the numerator and reduce the fraction, this limit would be -1/3 minus 1/3 T as T approaches 0, which is -1/3 milligram per hour. So the rate of change is -1/3 milligram per hour. Amount of medicine in 1 milligram of blood is being reduced through the system. That's why the answer is negative. Question number 11. The time t in seconds taken by an object dropped from a height of s meters to reach the ground is given by the formula t equals square root of s over 5. Determine the rate of change in time with respect to height when the object is 125 meters above the ground. In this question, s is the independent variable and t is dependent variable. We are looking for the instantaneous rate of change of t with respect to S when S is 125 meters. This rate of change is T at 125 plus H minus T at 125 divided by H, which is the same as limit of square root of 125 plus H divided by 5 minus square root of 125 over 5 divided by H as H approaches 0. To find this limit, we have to rationalize the numerator. 125 over 5 is 25 and its square root is 5. If we times and divide the numerator by the conjugate of the numerator of the fraction would be 125 plus H over 5 minus 25, and the denominator would be H times the conjugate of the numerator. The conjugate of the numerator is the square root of 125 plus H over 5 plus 5. If you take the common denominator and the numerator, 125 and 125 get cancelled, and the numerator can be written as H over 5. H and H get cancelled, and this limit would be the same as limit of 1 over 5 times square root of 125 plus H plus 5 over 5 plus 5 as H approaches 0. By direct substitution, this limit would be 1 over 5 times 10, which is 1 over 50 second per meter. The rate of change at S equals 1 over 25 is 150 second per meter. Next question, question number 13. Spaceship approaching touchdown on a distant planet has a height of h in meters and t in seconds, given by h equals 25t2 minus 100t plus 100. When does the spaceship land on the surface? What would be the speed of the spaceship when it lands? Assuming it descends vertically. When h is 0, 25t2 minus 100t plus 100 equals 0. We divide both sides by 25. It's going to be t2 minus 4t plus 4 equals 0, which gives us t equals 2. That means after 2 seconds, the spaceship lands on the surface. We are looking for speed that is instantaneous rate of change of height. Limit of h plus 2 plus h minus h of 2 divided by h as h approaches 0 is the instantaneous rate of change of height with respect to time, which is the speed at t equals 2. By calculating this rate of change, we'll see the numerator is 25 times 2 plus h to the power of 2 minus 100 times 2 plus h plus 100 minus 0. H of 2 is 0 divided by h as h approaches 0. If we expand and simplify this fraction, the limit would be the same as limit of 25h2 over h as h approaches 0. Reduced by h, the limit of 25h as h approaches 0 is 0. This means it lands on the ground in 2 seconds at the speed of 0 meters per second as we expected. Question number 14. A manufacturer of soccer balls finds that the profit from the sale of X balls per week is given by P at X equals 160X minus X2 dollars. A, find the profit on the sale of 40 soccer ball per week. We are looking for P at 40. The profit and X is 40. 160 times 40 minus 40 to the power of 2, which is $4,800. Part B, find the rate of change of the profit at production level of 40 balls per week. The answer of part B is instantaneous rate of change of P with respect to X when X is 40, which is limit of P at 40 plus H minus P at 40 divided by H as H approaches 0. If we calculate P at 40 plus H minus P at 40, we have 80H minus H2. Therefore, the instantaneous rate of change would be limit of 80H minus H2 divided by H as H approaches 0, which is the same as limit of 80 minus H as H approaches 0. That is 80. This means rate of change of profit is $80 per ball. The last part is asking to sketch the graph of the profit function and find out for what sales levels of X the rate of change in profit is positive. The graph of the function is a parabola downward. When X is 0 or 160, profit is 0. The maximum of the given parabola is when X is 80 and it is 6,400, and we are looking for values of X for which the rate of change of Px with respect to X is positive. That means for what values of X, the slope of the tangent line to the graph of the function P at X is positive. The slope of the tangent line is positive when the value of X is less than 80. Therefore, the rate of change of profit is positive when the sales level is less than 80. Thanks for watching.